correction appears inside the model before the sky changes. One filament bends sideways across the prediction grid. Operators keep watching the live survey beside it. Nothing moves yet. For several seconds, the structure holds. Then the observation refreshes. The real filament shifts into the same position the simulation already showed. Same angle, same drift, same correction. Nobody speaks at first. The model is supposed to follow the sky. Another filament bends across the grid. The telescope feed follows a few seconds later. A dim strand of light stretches between distant galaxy clusters against total darkness. It holds steady for a moment. Then the entire structure jerks sideways. Not far, just enough to feel wrong. The cosmic web shifts across impossible distances. Several bright nodes shift with it at the exact same instant, separated by hundreds of millions of light years, moving together like linked points on a screen being dragged out of alignment. The filament does not tear. It snaps slightly sideways, then settles again. Something that large should not twitch. Gravity can move structures across the universe, but it does it slowly, unevenly. Different regions drift at different speeds over unimaginable stretches of time. What appears here is synchronized. Fast. Coordinated before the eye fully accepts what it saw. Then it happens again. Two distant clusters jump together. The surrounding darkness stays perfectly calm. The galaxies remain visible inside the structure. Nothing explodes. Nothing collapses. The pattern simply shifts position for a fraction of a second, as if the universe attempted a correction and overshot it. For several seconds, the web looks stable again. A glowing filament hangs motionless between the clusters. Thin, quiet, almost organic. Then the alignment slips sideways one more time. Not random motion, not expanding space, a correction. And afterward, everything settles back into perfect stillness. The prediction layer updates before the observations do. A simulation grid updates across a black screen. Thin luminous filaments drift slightly out of alignment between galaxy clusters. One line bends sideways, then another follows. The movement is small, almost clean, like a graphical correction smoothing itself into place. The telescope data beside it does not move. For a few seconds, the sky map remains stable while the model continues adjusting the structure underneath it. Then the observation refreshes. The real sky catches up to the simulation. A filament shifts on the prediction map, and moments later, the observed structure jumps into the same position with the same angle change, as though the telescope output arrived late to an event the system already knew about. One observatory confirms it. Then another, separated by thousands of miles, resolves the same delayed correction. The sequence repeats again. Simulation. Pause. Observation. If the model is only reading telescope data, the sky should change first. Instead, the prediction arrives before the evidence. The map no longer behaves like a tool following reality. It behaves like reality is following. For a moment, the screens look calm again. The cosmic web hangs motionless across the display. Bright nodes connected by silent strands of light. Perfectly stable.
End the calibration.
Then another line shifts inside the model before the telescopes see it happen. Survey layers drift across the screen in different colors. One catalog sits slightly above another. A third arrives a fraction late, stretching the filament sideways as the system tries to merge them into a single map. Then the layers snap together. for a moment, this works. The filament aligns after correction. The sideways twitch disappears. Cluster positions stabilize. The prediction map and telescope output finally sit on top of each other without drifting apart. No sudden motion. No coordinated jump. Operators rerun the alignment process. Quietly. Methodically. Maybe the alignment slipped. That explanation spreads quickly because it protects something important. The universe remains stable. Only the translation layer failed. The sky itself never moved incorrectly. Human systems simply stitched different moments together in the wrong order. And if recalibrating the pipeline removes the twitch, then the problem can be controlled. The correction finishes. The filament remains perfectly aligned for several seconds longer than before. The correction completes across the entire map. The structure looks sharper than it ever did before. Thin strands stretch cleanly between galaxy clusters with almost surgical precision. Then the filament twitches again. This time the movement is clearer. After correction, the structure becomes sharper than before. A bright line slips sideways against the black background. Not blurred now. Not hidden behind synchronization artifacts. The motion cuts across the cleaned map with enough precision to measure directly. One catalog catches it. Then another independent archive resolves the same shift from a separate processing chain. The error gets cleaner. For several seconds, nobody changes the calibration settings. Operators stop rerunning the correction cycle and simply watch the stabilized map hold itself together around the anomaly. The surrounding structures remain perfectly aligned. Only the filament moves. If timing delays caused the twitch, correction should erase it. Instead, the cleaned data exposes the motion more clearly than the contaminated version ever did. Noise vanishes, leaving the twitch exposed. That realization changes the earlier relief immediately. The pipeline explanation was not protecting reality from bad data. It was revealing how dependent reality already looked inside the systems translating it. The correction process is no longer separating the sky from the error. It is carrying the error forward intact. The final map stabilizes without warning. No drifting overlays. No visible desynchronization. The filament settles into a fixed position between the clusters and remains there long enough for the room to relax around it. Prediction models. Live observations. Correction layers. Everything finally agrees. Then someone opens an archived map. An older survey image appears beside the corrected version. Same region. Same filament. At first, the mismatch is obvious. The earlier archive still shows the original alignment from before the twitch. A few seconds later, the alignment changes. Quietly. The archived image shifts sideways into the new configuration without any visible reprocessing cycle. The old map no longer disagrees. The cosmic web rewrites its own record. Operators begin pulling additional catalogs from different years.
Everything before
Independent archives. Older prediction layers. Separate observation histories stored long before the correction process began. One by one, the structures align too perfectly with the new pattern. The archive stops preserving the mismatch. If these records are independent, they should preserve the earlier mismatch. Instead, past observations, present maps, and future predictions now support the same corrected structure as though the instability had always been there waiting to resolve into consistency. For a moment, the screens become strangely calm again. Bright nodes. Silent filaments. Perfect alignment across every layer. And that is when the first twitch changes meaning. It no longer looks like the beginning of the failure. It looks like the moment the correction started. Everything before it now appears to have been wrong.
Before it now appears to have been wrong.